Hello and welcome to week 7 of IT in the Forge. Since the beginning of class, we've talked a lot about data being stored at one time or another, but not much about exactly how that process works. Let's find out more this week by taking a closer look at storage technologies. If you recall from the early days of class, data can be considered stored as long as it remains in the same state between the times in which it's intentionally manipulated. Take the first calculator, for example, the abacus. The position of the beads, once calculated, will remain stationary or in the same state until a hand reconfigures them for a new equation. Keeping that simple concept in mind will help you make sense of all the technologies that have been introduced since then. We'll skip ahead a few thousand years to the 20th century when the computer technology began to advance rapidly. The earliest form of storage for modern computers was paper punch cards. Paper was cheap, reliable, and could hold data indefinitely. Certain commands for the computer, and sometimes straight up binary, was physically punched into the cards to write programs. Now, given what we've learned already, this should make sense. A particular cell on a punch card could either have a hole in it or not, a 1 or a 0. These had to be fed into the computer in the correct order for the program to run correctly, and programs could consist of thousands of cards. The limitations of this method were apparent. It was extremely slow to process, and data could only be written to a punch card once. You couldn't unpunch a hole. An improvement upon this was something called delay line memory, which used sonic peaks and valleys, or sound waves, as a binary code. A speaker was set at the end of a small tube filled with fluid, and a pulse from the speaker would create a compression wave in the tube, recording a 1. Segments of the fluid that were not compressed were a 0. The drawback to this technology was that each bit had to be read one at a time and in order. This technology was relatively short-lived and supplanted by a familiar one, magnetic core memory, which is the predecessor of RAM. Remember that? This technology is where we really saw the split between what is volatile and persistent memory. We'll revisit these terms later, but for now just know that magnetic core memory was really fast, but it also was pretty small in terms of size. Around the same time, another magnetic technology was developed called tape drives. This became the preferred method for data storage and would stick around for a long time. In fact, it's even still used today for archiving purposes. Thin strips of magnetic tape were stored in rolls and run through reels. Just like magnetic core memory, segments of this tape were either positively or negatively charged, giving us a 1 or a 0. What set this technology apart was the manner in which data was retrieved or changed. A special component called the write head could magnetize specific segments of the tape, switching polarity. Another special component called the read head could detect the magnetism of specific segments. This is where we can bring back our analogy of the abacus. The state of a segment on this tape would not change until it was acted upon by the write head. It stayed either positive or negative and would be read as such until the write head could change it for whatever reason. Still, a major drawback for this technology, though, was that it was sequential in nature, so the tape had to be fast-forwarded or rewound to get to the needed data. The answer to the sequential problem was the magnetic drum drive. This was a large, rotating magnetic cylinder that was encapsulated in a shell of read and write heads. Like tape, segments of this cylinder were either negative or positive. The segment could be read or changed fairly rapidly. It just needed to wait until the rotation brought that segment to the correct read or write head to do so. Now, these drum drives were the precursor to modern-day hard disk drives, which we'll talk about now. Hard disk drives work the same way as drum drives did in the sense that they are constantly spinning, except these were much more compact, flat metal disks. Data on a hard disk drive is still accessed and changed by a read-write arm, though it is much smaller and more sophisticated than the enormous apparatus surrounding the drum drive. Data on a disk is organized into blocks via a scheme called logical block addressing. And the protocol, or set of rules, used to transfer data and interface with logical block addressing is SATA, or Serial Advanced Technology Attachment. This was a step up from ATA, which transferred data in parallel. Remember the difference between those two? Serial and parallel? Hard disk drives were the standard in persistent memory for decades and are still popular due to their relatively low cost. Let's take this time now to note the difference between persistent memory and volatile memory. RAM is what we call volatile memory because whatever is stored there will no longer exist once it receives no power. In other words, as soon as you turn your computer off, everything in RAM, with some exceptions, gets wiped. Not until your computer turns on again will it start to load and process data. This is another reason why it helps to think of it as your short-term memory. When you go to sleep, you aren't consciously thinking thoughts again until you wake up. You yawn, stretch, and before you begin your day, you think about what you did yesterday before moving on with today's tasks. That remembering what you did yesterday part is kind of like persistent memory. It's data that gets stored and stays or persists even when the system is shut down. Persistent memory has always been a must in computer systems, but as the pace of life quickened, it became necessary to be able to move persistent memory around more easily. Rather than ripping out your hard drive out of your PC case every time you wanted to take some data over to a friend's house, we needed a way to store data in a more mobile way. Enter the floppy disk. Even though it had a few predecessors, the floppy disk was the most ubiquitous mobile data storage option for a good while. It's even been immortalized in the save icon that you see all the time. It essentially worked the same as a hard disk, except the disk was a round and floppy piece of magnetic tape, encased in a hard plastic square for protection. The improvement upon this was optical media, which included something you're probably familiar with, the CD or compact disc. Optical media had tiny divots on its surface, causing light to be reflected differently. A laser sensor interpreted those different reflections as binary. The newest technology on the block for persistent memory is non-volatile random access memory, or NVRAM. You may have also heard this referred to as solid-state drives or SSDs. Now these use integrated circuits instead of a magnetized surface, which means no moving parts. One of the drawbacks of hard disk drives is that they rely on the very precise movement of a lot of mechanical parts, which eventually wear out over time. We have yet to really see the longevity of the newest SSD drives, but so far, no moving parts has produced longer-lasting products. There are two standard interfaces for NVRAM, and those are SATA and M.2. SATA on NVRAM works the same as it does on hard disk drives, and M.2 is a miniature PCIe format, which also transfers serially. And that brings us up to date on storage technology. As always, you can dive deeper into each of these technologies to work out their finer details of how they work. And as always, I encourage you to go out and learn as much as you can from other sources. Thanks for joining me today, and I'll see you next time in the Forge.